Hello class, hope you're doing well today. Today we're going to continue on our discussion of the nature of science to explore how we do science. So let's get started. So as we talk about how we do science, one of the major ways that we do science is descriptive science. So we're describing the world around us. And this is oftentimes the type of science that students forget about. So when we build a submersible that we send to the depths of the ocean that we've never been to before, and we describe the life forms that we see there, that is indeed science, and that is descriptive science. Or maybe we build a better telescope that allows us to see deeper into space than we've ever seen before. That is descriptive science. Or maybe we build a rover that we send to Mars or other extraplanetary bodies and describe what we see. That is descriptive science. So keep in mind, descriptive science is a very important aspect of science and should not be forgotten. Hint, hint. The other type of science that we do is hypothesis-driven science. This is also referred to as experimental science. This is the type of science that we probably think about more when we think about science. This type of science is generally guided by the scientific method. Now, when we hopefully you're familiar with the scientific method. I hope that you've been exposed to this at some point in your education so far. I want you to realize that the scientific method is not a rigid guideline. Okay, this is a general concept on how we do experimental science. One of the really cool aspects of the scientific method is that we humans, we innately use this to learn about the world around us. Not only have you been using this since you were a toddler, but you probably use the scientific method on a daily basis. So as we look at the scientific method, we start off with some observation. So maybe I go out to my car, put the key into the ignition, turn the ignition, and the car does not start. I've got an observation. My car just did not start. This is then going to raise one or more questions eventually. I might have some cursing. I might debate whether maybe I should just cancel the day because this is some bad omen or whatnot, or maybe I'm panicking on how the heck do I get into class or whatnot. Ultimately, I'm probably going to come back to the question, why did my car not start? So that observation will raise questions. In response to that question, we're going to propose one or more hypotheses. So we'll come and talk about hypotheses in just a little bit here, but these are proposed explanations for an observation. So some of those hypotheses might be things such as maybe the battery is dead, or maybe a squirrel got in and ate chewed on some of the wires in my car since it's been sitting in the garage for quite a while here. Maybe it's out of gas, what have you. Maybe the starter's broken. So these are hypotheses that we can have. In response to these hypotheses, we'll then carry out our experimentation. All right? So if my hypothesis is that the battery was dead, maybe I would try to jumpstart my car to see if that worked. So maybe it was the battery was dead. For me, in order to test whether the wires were chewed on or if it was the starter, I'd probably need a little bit more expert help. But those certainly would be things that we'd want to do. In the end, we'd then draw conclusions. So if I then try to jumpstart my car and that doesn't help at all, maybe I would tend to reject the hypothesis that the battery is the problem. Now, keep in mind we don't always follow strictly those steps in the scientific method. Those are a general guideline in science. Now, if I were to ask you initially, what is a hypothesis, you probably would have said an educated guess, or at least it would have gone through your mind that it's an educated guess, because this is how a hypothesis has typically been explained through grade school. What I'm going to ask you to do now is to set that idea aside, because we need a little bit more sophisticated understanding of what a hypothesis is. So let's take a look at a hypothesis with a little bit more sophisticated lens. So a hypothesis is a proposed explanation for an observation with a couple of guidelines behind it. First off, it must be testable. So that's a very important aspect that we need to keep in mind. When we propose a hypothesis, it must be within the realm of nature, and it must indeed be testable. So, for example, if my neighbor Jimmy comes over and sees that my car's not starting, and he says, well, it's probably a ghost, turning your engine off, not allowing it to start. It looks like you've got a ghost in your house too. That's not testable. We can't test a ghost. Or, maybe he's proposing that, maybe God just wants you to take the day off. Okay? That's not testable. We can't test God. And, if we take a look through literature in the past, most literature suggests that even if we could test a God, that's generally not a good idea. So a God or divine entity, by definition, is supernatural, thus beyond the natural world, and thus science can say nothing about that. It's not testable. It's not really within what we consider this narrow realm of science. Along those lines, we often have, we'll come back to that in a bit here. Another second aspect of a hypothesis is that it must also be falsifiable. So in terms of falsifiable, the idea is that there must be a chance that we could reject it. Okay? So a divine entity, the God or gods causing my car not to start, we can't reject that idea. Okay? A ghost, we can't reject that idea. We can't disprove that ghosts exist. All right? We can't explore the entire universe to see if there are any ghosts within the entire universe. Thus, we cannot disprove ghosts, or the idea of ghosts, if one should choose to accept them. So this is a very important idea within science, that things must be falsifiable. There must be a chance that it could be shown to be incorrect. Also, hypotheses cannot be proven with absolute certainty. Now, when we use the word proven, what we mean is that we are 100% certain, okay, that it is true. Keep in mind, one of our central tenets that we talked about previously is that all of our conclusions in science are tentative. That means they're subject to change. So we would never say that we have proven our hypothesis true, or that we've proven our hypothesis to be wrong. And in fact, if there's one word that really strikes a chord in this class, that is the 6-letter word proven, that we should not use that, all right? Because again, we do not have this 100% certainty, okay? If we test a hypothesis and it is not rejected, we would say that it is supported. So as we do science, let's take a look at this flow chart of the scientific method. We start off with some observation. So again, my car didn't start, raises a question. Why didn't it start? We propose multiple hypotheses. So maybe it's the battery, maybe it's the starter, maybe it's the ignition wires. Maybe somebody came in and took the engine out overnight. I don't know that. That's a hypothesis. And I don't know what hypothesis 5, maybe we're out of gas, right? So then we perform an experiment. So maybe I simply replace the battery, okay? If my car does not start after I replace the battery, I can reject that hypothesis. That leaves several hypotheses left. Maybe that it's the wires, ignition wires. Maybe it's the case that there's no gas. So again, I would perform a second experiment. And when we do an experiment, our goal ultimately is to reject some of these hypotheses. And in fact, as we look at the truest form of science, our ultimate goal is really to reject or falsify ideas. We end up with one remaining hypothesis that we accept. Okay? We might even test that hypothesis multiple times, and if it is supported, that would tend to confirm the hypothesis, but does that prove that that hypothesis is absolutely true? Well, it doesn't, because there could be another hypothesis which, when tested, also would be supported. Okay, so maybe we come down to the point where we're thinking it's gas, that we don't have any gas, but maybe it's not that we're out of gas, maybe that our fuel line was cut. In which case we'd really come up with fairly similar type results for some of these experiments. If our hypothesis fails, then we come back and we have to come up with new hypotheses. And then we perform more experiments. Again, our goal is to reject hypotheses.